So this is the first part of our lesson, which is 8.1 in Math 1316. This is just going to be the introduction and getting a first few examples in. You need to make sure you've got out your notebook paper, your book, or an ebook. And the cool thing about this is you can start and stop the video as often as you need to let all the materials soak in. When I gave you information in an earlier video about setting aside time for your class, this is what I meant. These are going to be your class times, just like we're in class. You get to see inside my book and all the stuff I've written, the notes that I've written to myself, and it starts like this. So I am on page 522, and I want to point out at the very bottom, and I have a smiley face. We've already done this. When you're looking at the bottom, you'll see the smiley face talking about sine is opposite over hypotenuse. That ought to sound fairly familiar with our SOHCAHTOA. And then when you have the reciprocals beside it. I'm going to go on up to the next page at 523. And at the top of 523, it talks about how to find some values. We've already done this. It mentions Pythagorean theorem, and it should on here somewhere, and so it's the exact value. So it's just the sides, not talking angles yet. But just looking at the sides, we've got Pythagorean theorem, we've got our SOHCAHTOA, we are ready to go. And then it just gives us a little information that says the values of the trigonometric functions of an acute angle are ratios of the lengths of the sides of a right triangle. This way of viewing the trigonometric functions leads to many applications. Hence the title of 8.1, Right Triangle Trigonometry, Applications. And in this fact was the point of view used by early mathematicians before calculus in studying the subject of trigonometry. I'm going on to page 524. And on 524, you see I'm at number 2, right here where it says use the complementary angle theorem. You need to underline that two acute angles are called complementary if their sum is and I don't know if you want to have flashcards, highlighter, underline, but somehow you put to memory that complementary means, and you may already know that from geometry, it means that they're going to add up to 90. And then it goes on a little bit further to explain that sine of some angle is the same thing as cosine of its complement. And it's going to keep showing us these relationships. Notice they put sine and cosine together, tangent, cotangent together, and secant and cosecant. In other words, you get to do some manipulation. Here's the theorem. Cofunctions of complementary angles are equal. Here's where it's cofunctions of complementary angles are equal, and here's what it means. Sine of 30 is the same thing as cosine of 60. 60 plus 30 equals 90. You can keep going with tangent. 40, 50 is 90. Secant, cosecant, 80, 10 is 90. A few examples on this. As you're looking at A, it says sine of 62. What in the world could that be equal to using the complementary angle? Sine is going to relate to cosine. We just subtract it from 90. The 90 minus 62. Tangent, and then they put it in radians, pi over 2. So not subtracting from 90, but subtracting from a pi over 2. And when you do a little manipulation on the fractions, we get cotangent. From tangent to cotangent. And pi over 12 to, and if you added these, 5 pi over 5 pi over 12, added back to our 1 pi over 12. That gets us to 6 pi over 12, better known as pi over 2 or 90. So a quick double check. C adds a little bit more in where it says, okay, wait, sine and sine. And you're like, wait, that looks familiar. Oh yeah, it's one of the Pythagorean identities. But it's not sine squared plus sine squared, it's sine squared plus cosine squared. Well, the cool thing is this works, this complementary angle theorem works even for squares. So sine squared of 50 is going to be the same thing as cosine squared of 40. And because of that, we can rewrite it to sine squared plus cosine squared, and then I even put a little smiley face. It is just 1. I'm going to get you to watch a video inside of My Lab Math, but I just had to point this out. It's going to talk to us about solving right triangles and some blah, blah, blah. But then it says, be sure that your calculator is in degree mode. I put LOL with a question mark because it's not very funny when it happens to you on a homework or on a test. But do make a note of that to be in degrees. And now you're going to go watch a video from inside My Lab Math. Go back and look at your assignment list and you'll know exactly what to do. But this was the introduction to 8.1.